Hi everyone, welcome back to my channel. This is Rahul. Today we will solve a popular medium level LeetCode problem, course schedule 4 using Java. So this problem involves determining if one course is a prerequisite for another, either directly or indirectly, given some constraints. So let's dive into it step by step and break it all down. So this is our question. Here we have a total of num courses and it labeled from 0 to num course minus 1, and we have a prerequisite array that shows dependencies between courses, and finally a query array where we need to check if a course is a prerequisite for another. So if you check this example, we have two num courses and our prerequisite is 10 and our queries is 01 and 10. So here the pair 10 only, that indicates that you have to take course 1 before you can take course 0, and course 0 is not a prerequisite for course 1, but the opposite is true. So like that we have to do this. So our approach is simple. First of all, we have to represent the courses and their dependencies using a graph. Then we have to use the depth first search to find a course is reachable from another. At last, we have to store the result in a matrix for efficient query. Alright, let's jump into the code and start. So here we have our main function. It takes three inputs. First, num courses, which is the total number of courses. Then prerequisite, which is a 2D array showing dependencies, and queries, which is also a 2D array where each query is asked if one course is a prerequisite for another. And we will return a list of booleans as the answer. That's the return type here. So first of all, we need to check if there are no prerequisite. So for that, I have to initialize some variables and prerequisite out length, then m queries. So we have to check whether there are no prerequisite. If n is 0, then we all know we have to the queries will return false because no course depends on another. Then we have to create a result list with false for each queries and return it immediately. So we have to create one result list which is boolean type, new array list. Then we have to write the for loop int I is 0, I to m, increment I. Then we have to add false if no prerequisite there. Then simply return result. Now we have to construct the graph to represent course dependency. So we have to come out of the loop first. list integer graph list and courses. So we have to go through the uh, array. So I will use one loop num courses, then increment I. So graph of I, we have to give graph of I is a list of courses that can be taken after completing course I. So that I have to initialize the array list. Now I have to use one for each loop in order to check for each prerequisite pair means AB just take. Then we add B to the adjacency list of A for prerequisites. Graph of P0 dot add P1 P of 1. Now we have to create a 2D Boolean matrix. Uh, I will name it as reachable. Is reachable because we are using data type new boolean. So is reachable of ij will eventually tell us if course j is reachable from course I. Initially all values will be false. Now we need to perform depth first search, which is the DFS. So for that we have to run DFS from every course to find all courses reachable from it. For that I will use one for loop. If is reachable is false means reachable of I is false. It means we haven't visited I yet. So we have to perform DFS from there. DFS I graph is reachable. Come out of the loop first. Now we have to uh, go for next one. Means once we have computed the reachability metrics, we need to answer the queries, which is simple. So list boolean. So result same like before, new array list. So we have to go through every queries for, so that I will use one for each loop. Q to queries. So for each query, UV. Okay, we have to check if is reachable UV, and we have to add it to the result list. That's it. Dot add is reachable. Now we have to return the result. So once we're done with this, we have to go for the helper function because we already written one here DFS. So we have to write that now. Private void DFS int. We will use three inputs, int current for the current course, then one graph, then is reachable to for the true or false thing. Just integer graph boolean reachable. Now we have to mark the current node as reachable from itself. So is reachable of current is true. Now we have to go through each element in the graph array, means graph list. So I will use one for each loop here also. For int um, neighbor graph of current. Okay. Now for each neighboring course, if it's not already reachable, we have to mark it as reachable, and we need to perform DFS. if not is reachable of current neighbor, then we have to mark the neighbor as reachable. Current and neighbor is true. Now we have to recursively visit the neighbors. DFS neighbor graph is reachable. So after DFS, we need to update the reachability of all nodes connected to the current node. So this ensures that any courses reachable from a neighbor is also reachable from the current course. For that, I have to use another loop. I to 0 is reachable. Total length increment I is reachable. Current I or equal to is reachable neighbor I. That's it. We can run now. Hmm, okay. Anything else? Okay, now. And then we have this. Um, graph of P zero your phone. Graph of high list. What I'm missing. Yeah, it's working. Sorry for the spelling mistakes. So you can see it's took only this much time with 100 percentage efficiency. So that's it for today's. We solved the problem using a graph, DFS, and reachability metrics. So this approach ensures we efficiently handle multiple queries after pre-processing. So if you found this helpful, don't forget to like, share, and subscribe for more coding solutions. See you in next video. Bye.